Welcome back, part 3. Okay, here we go. We are multiplying complex numbers now. And all we have to do is use FOIL. If you remember how to multiply binomials together, you can handle this. There is one little trick at the end, though, that you have to keep in mind, and we actually went over how to do that in part 1. So, let's look at the same two binomials, or same two complex numbers that we talked about in part 2. Okay, we're going to use this as our example. We're going to use FOIL, and I'm going to work this out long ways so that you can see it. Okay? F stands for first. We take the first two terms in our binomials, or our complex numbers in this case. 2 times 5 is going to give us 10. Okay? Our outside terms, so 2 and 6i. 2 times 6i is going to give us 12i. Alright? Our inside terms, 3i times 5 is going to give us 15i. Alright? And then our last terms, 3i and 6i, is going to give us 18i squared. So if we combine our like terms here in the middle, we end up with 27i. And so you would think that we would end up with an answer looking like this. 18i squared plus 27i plus 10, right? Well, it's not going to be that simple, because this part right here can be simplified. Remember, in part 1 we talked about what I squared actually is. I squared equals -1. So if we plug that in instead, we have 18 times -1 plus 27i plus 10. This now becomes -18 and can be combined with that term. So plus 27i plus 10. If we combine -18 and 10, we have -8 plus 27i. And that is our answer in standard form. Okay? It's important to note that any time you end up with I to any power, it can be simplified. Okay? You will never have a product of complex numbers, no matter how many you have, that's larger than 2 terms. That's going to have a real component and an imaginary component. Now, it's possible that you can end up with just a real component. We're going to find out why. Division. So we're basically going to take the same example we had before, with the same two complex numbers, but instead we're going to be dividing them. So now I've got 2 plus 3i divided by 5 plus 6i. Now, the way we do this is we have to multiply by a conjugate. Okay? A conjugate, we take the conjugate of a plus bi. The conjugate is actually going to be a minus bi. It's the same two terms, the same real component, the same imaginary component, except the sign in the middle is now changed. What that's going to do is going to help cancel out any middle terms that we would end up with. We'll see how in just a moment. Just like when we were rationalizing denominators of fractions, like we had 1 over the square root of 2, we wanted to get rid of the radical. Well, here we need to get rid of the complex number in our denominator. Okay, what we did was we multiplied both top and bottom by that radical to get rid of it. And we'd end up with 2 now on the bottom, square root of 2 on top, right? We're going to do something similar here. The conjugate of this, 5 plus 6i, is 5 minus 6i. Okay? We're going to multiply top and bottom by the same thing, because this fraction, the value of this fraction is 1. Okay, so we're not changing the value of our original problem. So once we do this, I'm going to start down here. we're going to do the same thing. 2 times 5 gives us 10. Okay? 2 times negative 6i is minus 12i. 3i times 5 is positive 15i. And then 3i and negative 6i give us negative 18i squared. We're going to simplify that shortly. Down on the bottom, we get 5 times 5 is 25. Now, plus 6i times 5 is going to give us positive 30i. Negative 6i times 5 is going to give us negative 30i. So, those two things are going to cancel out. So, we have plus 30i and minus 30i. Those are going to cancel each other out. That's why this is so helpful. And then we have plus 6i and minus 6i gives us negative 36i squared. Now again, we're going to end up simplifying this. So, we know that this basically becomes the negative version of our term here. So, the I squared cancels out and we change this sign to positive. So it's now 10 plus 18. Gives us 28. And then we combine our like terms here. So negative 12i and 15i give us plus 3i. So our top is now simplified. Bottom, we now have 25, the same thing happens here. I squared changes the sign in front. So we're adding 36. Okay? Let's combine some more. 28 plus 3i remains on top. 25 plus 36 gives us 61. Now, we're not quite done yet because we always want to leave things in standard form. Alright, so we're just going to split up our numerator and create two separate fractions. So we're going to end up with 28 divided by 61 plus 3 over 61i. And that is our answer in standard form. And it doesn't show up too well on my camera, so I'm going to darken it up there for you. Better? Good. Now, so this is our answer in standard form. That's how we divide complex numbers. There's one more little thing I want to show you. What if our denominator is not that complicated? Say I have 2 plus 3i again on top. But instead we have, we'll call it 4i on the bottom. Alright? Do we really need a conjugate here? No, not really. The only thing that's a problem is that guy, is the I. So if we multiply top and bottom just by I, we can get rid of it. Alright? So this gives us I times 2 is 2i. 3i times I is 3i squared. And this becomes 4i squared. Well, all we have to do is simplify. That cancels out, changes the sign in front. Same happens here. Okay? So we end up with 2i minus 3 over negative 4. Alright? Well, we want to put this in standard form. So we're going to switch places. Negative 3 plus 2i over negative 4. And now we're going to split it up into standard form. So negative 3 over negative 4 plus 2 over negative 4i. This, of course, can be simplified a little more. 3 over 4 minus 1/2 I. And there is our answer. Okay? So, we talked about the I to any power. We talked about addition and subtraction of complex numbers. And now we talked about multiplication and division of complex numbers. So this covers the whole spectrum of what we talked about in class. Hopefully this helps you out. If you have any more questions, you know how to get into contact with me. See you guys.